All right, here's our Chapter 6 review video. I'm going to suggest you get those note cards out that we had. We had the graphing transformations, there were two sides, and then we had the other one that was linear arithmetic on one side and exponential and geometric on the other side. And this is the card I'm going to focus on as I go through the first part. Okay? So, the question, so make sure you read the directions, but it says for each question, determine if it's linear or exponential and write an equation that models the function, and pay attention to the scale on the axis, just, so you don't mess up. So remember, exponential multiplies each time. We note its shape. If there's an equation, the variable is an exponent, and in linear, we note its shape. It's y equals mx plus b. There's no exponent. And this is adding or subtracting an equation. So first one, just by looking at it, this is exponential. It actually happens to be exponential decay. So I'm just going to abbreviate that. So what's my y-intercept? So it's 0, 4. There is no m. Instead, there's going to be g. And in our note card, we wrote to find g, you're going to take a term or a y, and you're going to divide it by the previous term or a previous y. So I'm going to pick a y, so I'll use this one. And then I need to go for a previous y, or a different y. So I could go for this one, and that is negative 1, 8. Or I could go for this one, and this is 1, 2. So let's say I pick 2. Then its previous y is 4. Or I could pick 4, and its previous y is 8. So when I take those fractions and I simplify them, I get a half, and that's my g. So now I'm ready to write the equation. Y equals my y-intercept times a half, and then I put my exponent, the x power. Next one, is this linear or exponential? So what I always go for is it linear. So are they adding? So here they add 10, here they're adding 20. So they're not adding the same amount. So I'm going to guess it's exponential. So what are they multiplying by? Because it's getting bigger, they're always multiplying by 2. Again, if you don't see it, take a y and divide it by the previous y. Or take this y and divide it by the previous y. Either way, when I simplify those fractions, I get 2. And again, that's what I'm multiplying by. My y-intercept is 20. I do not have an m. Instead, I have a g of 2. And now I can write my equation. So the y-intercept times 2 to the x power. And again, you guys, if you want to put this in parentheses, you can. You don't have to. Next one, that's obviously linear. So the y-intercept is 0, 12. Remember, on the mile marker, you have to put the 0. There is no g, so what I want to do is figure out my rise over run. So I just need to go from one spot to the next spot. So from here to here, that's easy. But pay attention to the scale. So when I go from 9 to 10, I'm going up 1. But when I go from here to here, I'm really going from 6 to 4, so I'm really going over 2. So be really careful. That's why I noted the scale. So the rise is 1 and the run is 2, and it's going to be negative because my slope is going downhill. Okay? The other way you can do it again is to take 2 points. So this point right here technically is 6, 9, and the point next to it is 4, 10. And remember, you have the slope formula where it says you can subtract the y's and then subtract the x's the same way. So since I did 10 minus 9, I'm going to have to do 4 minus 6. And when I do that, I get 1 over negative 2, which is the negative half. So you've got a couple ways you can find the slope. Oops, let me move this. All right, so my equation, I'll be using the y equals mx plus b. So y equals mx plus my b. All right, next one. Let's see what's going on here. Well, so again, I always look for linear. So here I'm subtracting 6. That works. 5 minus 6 is negative 1. Negative 1 minus 6, or subtracting 6, is negative 7. So this is linear. The y-intercept is 5. I do not have a g. Instead, I have an m of negative 6. And now it's y equals mx plus my y-intercept b. All right, 5. This is linear. I can see that just from the picture. My y-intercept is 4. The slope, again, I can do the rise over run. So again, I got to look at the scale. I'm going up 1 spot, but I'm really going up 2. And then from 0 to 1, I'm going over 1. So my rise is 2, my run is 1. Since the slope is going uphill, it's going to stay a positive 2. And you can write 2 over 1, that's fine. There is no g. Again, the other way is to take points. So I had already written 0, 4. And then I could take this point, which is 1, 6. And I'm going to subtract my y. So I'm going to subtract the y's as 6 minus 4, which means I'll subtract the x's as 1 minus 0. And when I do that, I get 2 over 1, which again is 2. So now my equation is y equals mx plus my b. All right, number 6. So looking at this, it's subtracting 25. This is not subtracting 25, so it's definitely not linear. That's going to be exponential. It's going down, so this is a little bit tougher. I know they're dividing by 2, but exponential is always multiplying something. So I'm going to pick a y, and I'm going to divide it by the previous y, or I could pick this y and divide it by its previous y. Whether I type this into my calculator or this into my calculator, I'm going to get a half. Okay? So that's my g. I don't have an m. My b is 50. So now I can do my equation. Y equals the y-intercept times my g. And again, you can put this in parentheses if you want, to the x power. Okay? All right, next problem. This is definitely exponential. It's growth because it's growing. So here's 7 and 9. They both go in here. So the y-intercept, the scale is going by 2. So I'm going to assume that this is 0, 3. There is no m, so what's my g? Well, I want to go from one term to the next term. So 0, 3, the next term, I could pick this one. It's 1, 6. Or I could even do this one, which is 2, 12. So when I want to go for g, I can take this y and divide it by its previous y. Or I can take this y and divide it by its previous y. Either way, when I divide those, I get 2. So now I can do my equation. Y equals the y-intercept times g to the x power. So the next one, here's 9. This is also exponential. This one's decay. That means my g will be a fraction. It will be less than 1. So what's the y-intercept? So that's 100. So go ahead and write that. So what's another point? I have to go to this one, for instance, and that's 1. And the scale is going by 25, so this is actually 25. And I think that's all I'm going to probably pick, because this one, you know, I think it's about that, but these are pretty easy to work with. So I'm going to take this y of 25 and divide it by its previous y. And when I'm done and I simplify this fraction, I divide both by 25, I get 1/4. Now if you put this in your calculator and you get the decimal version of 0.25, that's fine. You can use 0.25. So we'll actually do that here. So now y equals my y-intercept, 100, times my g, 0.25. You could use the 1/4 there to the x power. And that's the first page. So can you tell me if it's exponential or linear based on all these different ways? All right, next sets. So we're going to graph each equation, and below is a t-chart to use, and be sure to show all important features. So points, get a couple points on, they're asymptotes. Asymptotes. Remember, in exponential equations, this k number that's added on, well, we wrote it here specifically for exponential. The k number that's added on is your wall. That's your up or down number, and that's your wall. So when I'm going through these, I definitely want to look for a wall if it's exponential. So first of all, this one's exponential. I don't see anything added on. So if I have a wall and I have to add something, I add 0, because adding 0 doesn't change it. And I do want you to draw on the wall. All right, so my y-intercept is 2. And if you want to make a t-chart, you can, starting at 0. And g is your growth factor. So there's a couple ways you can get some more points on here. One is to actually put 1 in here. 4 to the first power is 4. 4 times 2 is 8. Put 2 in here. 4 squared. 4 squared is 16, and 16 times 2 is 32. Or I could put 3 in here. 4 to the third power is 64, and 64 times 2 is 128, which this is never going to fit on the graph. The other way is once you get your y-intercept of 0, 2, your growth factor is what you're always going to multiply your y's by. So 2 times 4 is 8, 8 times 4 is 32, 32 times 4 is 128. So anyway, I'm going to graph these. There is no left-right number, there is no up-down. So once I get these graphed, I'm done. So here's 1, 8, and here, and 2, 32. So again, growth, we know the shape. It's coasts, but it can't touch the wall or cross that wall. Okay, linear, so this is y equals mx plus b. So again, their table is here if you want it. M is technically negative 1/3, and b is 2. So remember, b is by itself, b is where you begin. This line, because of the negative slope, will be going downhill, so I'm going to go up 1, and to get the downhill look, I'm going to go to the left 3. Because now when I connect those, I get the downhill look. Or I could go down 1 and to the right 3, down 1 to the right 3, until I get enough on there. If you're going to pick points, remember you have to pick numbers that would multiply well with 1/3. So 0 would multiply well with 1/3. 3 would multiply well with 1/3. 6 would. So for instance, if you put 0 in there, 1/3 times 0 is 0, and 2 minus 0 is 2. If I put 3 in there, 1/3 of 3, so write it down here, 1/3 of 3, that's just 3 over 3, that's 1. So I get 1, and 2 minus 1 is 1. And I could put 6 in there, so if I did 1/3 of 6, that's just 6 over 3, which is 2. So 1/3 of 6 is 2, and 2 minus 2 is 0. And those are the points I just graphed, 6, 0, 3, 1, 0, 2. And then you can connect them for your line. And again, make sure you're putting arrows, because sometimes you have arrows, sometimes you don't. These have arrows. I put arrows there. All right, this is exponential, so I'm going to start with 0, my y-intercept, which is 50. And remember, it's going to be going down. So when I pick points here, what I want to do is we had talked about, and we'll make sure we add this to our note card, is when you make your t-chart, do you want to use positive numbers or negative numbers? So if it's exponential growth, then in your t-chart, you want to use x to be 0, 1, and 2. But if it's decay, and you're picking values for x besides 0, you want to use negative 1 and negative 2. And I'll show you that again right in just a moment. So I'm going to use, I'm going to go in order, negative 2, negative 1, and 0. And the reason why, again, is if I put negative 2 in here, what negative 2 is going to do, what the negative is going to do is flip it so it's 5 and 5 squared. So when I do 5 squared, that's 25. And then 25 times 50 is, which will never fit. And then I'm going to put negative 1 in there, which flips it to 5, and 5 to the first power is 5. 5 times 50 is 250. So does that fit? No, that doesn't fit. Does 0? We already know what 0 is, so let's put 1 in there. So 1/5, whoops, I'm running out of room. 50 times 1/5 to the first power is a fifth, and a fifth times 50 is 10. So with 110. And I think that's all I'm going to do, because I also want to get my wall. So what's that number that's added on is 0. So here's my wall. Whoops, that's not a very good wall. But then what's going to happen is just with these 2 points, I got enough that I can coast and come along the wall. And I'm doing this one-handed, so sorry if that didn't turn out very well. And that's all I'm going to do for this portion of the video. The next part will be starting with questions 13 and 14.